Good evening students. Today we will study the first law of thermodynamics. In first law of thermodynamics, we will try to find the relationship between heat, work and internal energy of the system. As per the first law of thermodynamics, that energy of a system will be conserved, and the general principle of conservation of energy will be implies, as per the first law, delta Q will be equal to delta U plus delta W. Here delta Q is heat supplied to the system by surroundings. Delta U would be change in internal energy of the system. Delta W is work done by the system on the surroundings. So in this given relationship, we need to understand that heat supplied to the system by surrounding will be equal to the change in internal energy of the system plus work done by the system on the surrounding. Okay, or in other words, the heat supplied to the system goes partly, the heat supplied to the system will go partly to increase the internal energy, and the rest in the work done by the system on the atmosphere or the environment or the surroundings. This equation will be known as the first law of thermodynamics. The alternative form of this equation is delta Q minus delta W will be equal to, see, the thermodynamics first law is simply the general law of conservation of energy which will be applied to any system in which the energy transfer from or to the surrounding is taken into account. In a isothermal expansion of an ideal gas, the delta U will be 0. So delta Q heat given will be the change in heat supplied to the system would be equal to the work done by the system on the surroundings. This is a particular case. In the equation, delta Q is equal to delta U plus delta W. If I put the value of the change in work as pressure multiply with change in volume, then delta Q will be equal to delta U plus P delta V. This is another form of thermodynamics first law. The next important thing is specific heat the specific heat capacity let's say we denote it with S will be equal to delta Q upon delta T. Let's say suppose an amount of heat delta Q is supplied to a system. Okay, that is sustainable change. We are finding now after this heat we are applying to the system, we are observing a sustainable change in temperature. Okay, that is delta T. Change in temperature from T to T plus delta T. Then the specific heat would be, the specific heat capacity would be the ratio of the amount of heat supplied, that is delta Q, and change in temperature. See, the delta Q and so do the S will be proportional to the mass of the substance. Further, it could also be depend on the temperature. For example, a different amount of heat may be needed for a unit rise in temperature at different temperatures. See, if I have a different temperature, then to increase the temperature by 1 unit, I may need to give different amount of heat to the same system. So, specific heat capacities also depend on temperature.